third time lucky. Newton se eerste wet sê vir ons, as 'n voorwerp van 'n toestand van rus bly of teen konstante snelheid bly voortbeweeg, tensy 'n eksterne krag daarop inwerk. Okay, so let's break it down into its two different parts. An object will remain at rest. Okay? So, kyk rondom jou na die voorwerpe wat op jou bank lê. Stem julle saam, hulle almal is in rus. Nee? They're not moving at the moment. What will cause them to move? An external force being applied. Jy wat dit optel, jy wat dit omstamp, aardbewing miskien wat dit omgooi? Nee? Okay. So any external force will cause it to start moving. Daai is die maklike deel daarvan. The second part of it is a bit more complicated. Okay? And this is where the law of inertia comes in. Traagheid is die woord waarvoor ons hier soek. Okay? In Afrikaans is traagheid, English is inertia. If you are driving somewhere, okay, and your mom or dad or older brother or sister, whoever is driving, is heading towards a robot and it's green, but now it goes orange. What do? Hopefully, they brake. What do? Wat gaan? Nee, ons gaan nie vinniger nie. Ons breek, okay? Kom is 'n perfekte wêreld, almal breek, né? Jy sit nou langs aan in die passasierssitplek. Imagine you're sitting there and you're speeding towards a light, but now they apply the brakes. What does your body do? Jy maak so, né? Hoekom? Want traagheid. You want to keep moving at the speed that you are moving. That is Newton's first law. Nie jy is vertraag nie. Jou liggaam ervaar hierdie wet van traagheid om te sê you're currently moving at 100 kilometers per hour. That is your velocity. And you prefer to keep moving at that. But now an external force is being exerted on you. Okay. Dit is hoekom ons seatbelts dra. If you were not wearing a seatbelt and you were to be in a collision, you were moving at a certain velocity, now you're in a collision. And now there's nothing to prevent you from keeping on moving at the constant velocity that you are moving. So met ander woorde, dan breek jy deur die voorruit en jy word beseer. This is why we wear seatbelt, okay? Om nou by Asriek se voorbeeld aan te sluit. Some of you say your parents accelerate. I don't believe it. Law-abiding citizens. Julle kan ook nie ry nie, né? Okay. Have you guys experienced the feeling of being pushed back towards your seat as well? Like when you accelerate, it feels like you're going like this, né? Dit is ook traagheid. That's also inertia. Because you're moving at a slower speed and now suddenly the car that you are sitting in is accelerating. So you're almost still a few seconds behind, né? Maar dan die bank wat agter jou is, druk jou dan vorentoe. En dan na rukkie gaan daai gevoel mos weg. You're still moving faster than you used to be, but now you and the car has been accelerated to this new velocity. So dan beweeg jy weer teen 'n konstante snelheid. Dan ervaar jy nie meer daai snaakse gevoel van of vorentoe of agtertoe getrek word nie. Remember we said acceleration is a change of direction as well. Het julle al gesien as jy in 'n kar ry en jy gaan om 'n draai, dan voel dit asof alles in die kar die kant toe wil leun, né? If you're turning to the left, then it feels like everything is leaning to the right, or at least moving in a straight line. Selfde storie, want huidiglik beweeg jy in 'n reguit lyn. Nou versnelling sê jy het van rigting verander. So everything in the car wants to keep moving in that direction, but the car is moving in this direction. Verstaan julle hoe ons hierdie ene kan toepas in die wêreld rondom ons? Okay. Now there's not a lot of anything else that we have to say about this. Inertia is not a force, it's just a property of matter. The mass of an object is a measure of its inertia. So met ander woorde, hoe swaarder 'n voorwerp is, hoe meer traagheid gaan hy ervaar. Okay, that's why if you drive to Cape Town, then if you went just through the tunnel, then they'll tell the lorries to start decelerating, to start applying the brakes, né? Want 'n lorry weeg baie meer as wat 'n kar weeg, so met ander woorde, hy moet vroeër begin breek. Anders gaan hy in iets vasry. So the larger the mass of an object, the more difficult it is to move it from rest into motion. So hoe moeiliker is dit om dit aan die gang te kry en hoe moeiliker is dit om dit te laat stil staan. Okay. All of these definitions will be on your white notes. Ek het mos julle aan die begin van die jaar daai wit notas uitgegee van hierdie ene. Okay, Newton se wette is ook in daai. Goed. Just as a No, we don't have time for this. No, we don't have time for quick tidbits on the side. Okay. So jy moet traagheid se definisie ook ken. It's the resistance of an object to change its state of motion and rest. Met ander woorde, hy gaan net van sy konstante snelheid of sy rus verander as daar 'n eksterne krag op hom uitgeoefen word. Okay, so this was Galileo's experiment. So Newton was the one who formulated the laws, but Galileo did this experiment. Het julle al daai ene gesien van die balletjies wat so opgetrek word en dan val hy teen hulle en dan beweeg hulle so tik tik tik, né? Okay, sort of the same thing. So this was a frictionless surface, not completely frictionless, but he did what he could to make it frictionless. En toe het hy 'n balletjie laat rol en toe sien hy die balletjie rol elke keer weer tot dieselfde hoogte toe. Okay? After a while it does decrease, but that's because this isn't a perfect world, so friction. Okay? But if you were to get a completely frictionless surface, this can go on for infinity if you're doing it in a vacuum, so also no air resistance. Okay, so as jy 'n balletjie het, heeltemal 'n wrywing, wat gaan jy nog laat val? Oh my word. Die wind is die eksterne krag. Hou net alles vas asseblief. Hy's besig met 3 ander vlakke se huiswerk ook. Dit is wat hier aangaan. Maar moenie. Ek gee nie nou vir jou wiskunde nie, sit weg. Okay, goed. As jy 'n heeltemal 'n wrywinglose oppervlakte gehad het met geen ligweerstand nie. In teorie sal daai balletjie vir altyd aanhou beweeg na dieselfde hoogte toe aan albei kante. Okay, want daar's geen eksterne krag wat daarop uitgeoefen word nie. Toe het hy gegaan en hy die slope gaan kleiner maak. En toe sien hy dit maak glad nie 'n verskil nie. In other words, it doesn't affect the speed at which it reaches the bottom doesn't affect how high up it goes. Hy hou heeltyd aan om met dieselfde hoogte te bereik. Okay. Ek het al vir julle so baie verskillende voorbeelde gegee. Ons gaan nie omdoen nie. Okay. And like I said, this is why we wear safety belts. So, they love asking this as an application question. Okay? So, let's of jou sê, Newton se eerste wet, geef my die definisie van Newton se eerste wet, la 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 la. En dan sal hulle vir jou sê, gee 'n praktiese toepassing of verduidelik hoekom ons veiligheidsgordels dra. And then you have to relate that to the law of inertia. Okay.